Okay, this video is going to help us with taking, oops, okay, it's doing the wrong video, but this video is helping us do some review of how we started the chapter, working with vertex form for an absolute value and also a parabola, and getting ready for that quiz that you've got coming up, or that some people haven't taken. We did this in the class as quiz prep. Okay, so on the first one, if we're describing in words what is happening in this picture or in this graph, and first of all, it's an absolute value. So remember, absolute values are going to be V's. Then we can look at this and say, well, it's a vertical stretch. And the -3 is going to be moving it left and right. It's the opposite of what we think. So left 3, and then the +6 is going to move it up 6. The vertex is the opposite of what's with the x, so 3, and then the number on the end. So now we're going to graph it. So we got to start at 3, 6. Let's see if I can do this. Okay, so at 3, 6, we are right here. Okay, now I taught you originally with a pattern that for an absolute value, over 1, up 1, over 1, up 1, except when you've got a stretch or a shrink. Now, that works. But sometimes we get some quirky fractions. This one is not. But sometimes we have to graph like 2/7, 3/8. That gets really complicated trying to figure out where the point is. So because absolute values are V's, they are lines. And this number in front of it, that is the slope of the line. So the slope of my line is 2 over 1. So the slope at the top number controls the rise. This is positive. We're going to go up, but we have to go either direction. So then we're going to go right and left. So as I'm graphing this, I'm going to go up 2 and right 1, up 2 and right 1. On the other side, up 2 and left 1, up 2 and left 1. And there is my V. And oops, not very line. And we've graphed our 5 points, and we can identify now everything. So the domain is negative infinity to infinity, and the range, it starts at 6 on the y with the bracket and goes up to infinity. All right, let's look at the next one. On the next one, the negative in front is a reflection, so it's going to tip it over. There's nothing inside the x, so it's not going left and right. And then the -7 is going to be down 7. So my vertex, the opposite of what's to the x, is 0. And then we go down 7, so -7. When I'm graphing this one, 0, -7 is right here. Now again, you can use your pattern, but this is technically the slope. So my slope is -1 over 1, which means I'm going to go down because that's the rise. And because we need it both ways, so let's go right and left 1. So over here, I go down 1, left and right 1, down 1, left and right 1. And there is my graph. Okay, these are absolute values. These, because they have the squared, now these are going to be parabolas. So let's talk about what's different here. The transformation here, the negative is the reflection. So we know it's going to be opening down. The +4 inside is going to be left 4 because it's the opposite of what you think with the x. The -6 is going to be down 6. Our vertex is -4, -6. Now let's graph it, and we can write the domain and the range. Oh, which I forgot to do over here. Oh, guys, I did a bad job. Because do you know what I did not pay attention to? I was going too fast. I did not pay attention. This was an inequality, and I didn't write the domain and range. Well, we can do the domain and range. This is negative infinity to infinity. Don't miss that. Now the range, remember, it always goes from the bottom up. So we're starting at negative infinity, and it stops at -5. Okay, but what I forgot was this inequality. We've got to figure out the shading. So we have to pick a test point. So I'm going to pick 0, 0 because it's definitely outside of my V. So I can tell what I'm doing. So I'm going to put in a 0 for X and Y. So I get 0, absolute value 0 is 0, -0 doesn't exist, so that's just 0. So 0 is -7. So is it true that 0 is greater than a negative number? Yes, absolutely. So since 0 is on the positive side, I'm going to shade over here. Okay, and now I'm going to pay better attention to these problems to help you. All right, let's graph and then we'll find the domain and range. The vertex, -4, -6 would be right here. This one, let me try that again so I can actually get it on the point. This one is opening down because of the reflection. And then with the absolute, excuse me, with the parabola, you have to use the pattern. The absolute value, the slope is probably more efficient, but the parabola, the pattern is. So the pattern is going to normally go over 1, up 1, but because it opens down, I have to go over 1, down 1. And then we go over 2 and down 4. And there's our parabola. Now this one has an equal sign, so I don't need to shade. I'm only going to shade when there's an inequality. Okay, but I do need the domain and range. So negative infinity to infinity starts opening down, so negative infinity, and it stops at -6, the bracket. Okay, let's try this one. Transformations, the 1/2, that's a vertical shrink. The +4 inside, that's left and right. It's the opposite. So it's going to be left 4. The -6 is going to be down 6. Very similar to the last one. Okay. Vertex is -4, -6. We don't even need to see the picture. We have this. Now, there's a couple things. Because this is a less than or greater than, this is when we're going to have the dashed line and the open circles. So we do need to pay attention to that. So I'm going to go to -4, -6, which is right here. And normally for the pattern, I would go over 1 and up 1, but I have to go half that. So I'm going to go over 1 and up a half. And normally I go over 2 and up 4, but I have to go half that. So I'm only going to go up 2. And there is my parabola. So the range we can easily do now. It's going to go from -6 to infinity. Notice when they're down, they start with negative infinity. But now we have to figure out the shading. So we're going to pick a test point. Now 0, 0 is a little iffy. It's iffy because I'm not quite sure exactly where it lands. So I'm going to pick something that I know for sure. So I like this point right here. And I purposely pick -4 because when I plug it in, I'm going to get a 0. And those are always easier to work with. So I have 0 is less than 1/2. And then 0 plus 4 is 4 squared minus 6. So I have 0 is less than 4 squared is 16. Half of that is 8, and 8 minus 6 is 2. Is 0 less than 2? Yes. So where my test point is true, so this time I'm shading inside of my parabola. Okay. This time we want to write the equation given the information. So we want an absolute value graph. So we're going to have y equals, and there's no, for stretches or shrinks, there's no number in between. This is x. Inside is the left and right. So it's going to be left 6. So it's the opposite of what we think. So it's actually going to be +6. And then it's going to be up 5. So this is +5. Now this one said it's a parabola. So remember, a parabola, we have this form for vertex form. So when I write that equation, I'm going to have y equals, there's no vertical stretch or shrink. Oh, but look what it does say. It opens down. So because it opens down, we have to have a negative in front. And then this is going to be x plus 3 squared, and then minus 7. All right, now we're still going to keep writing equations, but this time we're doing it from the graph. These first two are v's. So these have to be absolute values when it's a v. When it's a u, it's a parabola. Okay, so I find the vertex, and that vertex looks like it's at 2, -3. Okay, it's opening up, and if I notice, it's going up 1 over 1, so I know there's going to be no stretch or shrink. So we have y equals the absolute value of x, the opposite of the x, so -2, and then the y -3. All right, let's see what happens here on this one. My vertex right here is at 3, 2. So I'm going to have y, and then this is going to be x -3, and then +2. We notice it's going over 1 and down 1, so there's no stretch or shrink, but because it's going opening down, we do have a negative. But now we have to figure out the shading. So let's pick a point. Well, we know at 0, 0, it needs to be true. So when I test it, I'm going to put in 0 for x and 0 for y. So I'm going to have 0 and then negative 0 minus 3 plus 2. Well, this is negative 3. The absolute value is positive, but then the negative outside makes it negative. So negative 3 plus 2 is negative 1. And I have 0 and negative 1, and I need it to be true. Well, 0 is greater than 1, and it's a solid line, so it's got to be greater than or equal to. All right, these are parabolas. These are the u's. This is the x squared. Okay, so if I'm writing this one, this vertex is at negative 4, 3. So this is going to be an equals because there's no shading. So I have y equals. And if I look, this one's a little bit hard to read because this is at 3 right here. And they went over 1, down 1, didn't they? And then they go over 2 and down 4, which looks complicated on this one, but there's no vertical stretch or shrink. So this is going to be x plus 4 squared plus 3. Last one, my vertex is 4, 0. So I'm going to have y, x minus 4 squared, and then I don't need to write the plus 0. Okay, now we need to plug in the test point and see if we can make it work. Well, we're looking at this and I can see that at 0, 0, it's false. So I'm going to plug in 0 for this. So I have 0 and then 0 minus 4 squared. So that's negative 4 squared is 16. So I need a situation where it's false with 0 and 16. So currently 0 is smaller, so I need it to be greater than, and it's a solid, so it's greater than or equal to. And that is my sign here. This should help you prepare for quiz 1.